Hey gang, here we're going to go through at least one example of constructing a confidence interval, and we're going to make it a 95% confidence interval. Okay. And remember what that means. A 95% confidence level means that if we construct many 95% confidence intervals, we expect about 95% of them to capture the true value of what we're looking for. And what we're looking for is the mean age of the Milwaukee Brewers. So 95% of them to capture the true mean age of Milwaukee Brewers players. Okay, so we're saying that again, if we construct many of these 95% confidence intervals, we can't just construct 1 or 10, but many. We would expect about 95% of them to capture the true mean age of Milwaukee Brewers players. Okay, now I'm going to show you how I've set this up. I'm not going to expect you to do all of this setup. I'm going to mainly what you're going to be focused on is this section over here, the mean, the standard deviation, the lower bound, and the upper bound, and then an interpretation of your results. Okay, so just to show you what I've done over here though, is in column A, I've just given each player a random number, and it's a random number between 0 and 1, so they all have different random numbers. Then I've labeled each player with a number 1 through 50. There are 50 players. Okay. And then over here, what I've done is I'm going to select a sample of 5 players. And so again, you don't need to understand all of this, but if you're interested, I want to show you this formula here. So what this is doing is it's doing a few different things here. We're going to start on the inside part of this here. We're going to start with this large. And so what large does is it's saying look at A2 to A51. So it's saying look at the values in column A and then return the first largest value, the number 1 largest value. Okay, so oops. So that's what that part is doing. Okay, so it's saying look in column A, find the largest value. This match part then is saying, okay, match that largest value with a value in column A. Okay, so it's basically just saying, find the largest value in A and tell me what row that largest value is in. Okay. Then what I want it to do is I want it to look up that number. So right now, maybe the largest value is this 0.956 that's over here. Okay. If that's the case, and actually it's not, let's see here. Right now the largest value is this 0.988. So it's saying, all right, find the largest value, 0.988, it did that. Then match the row that it's in. So it would tell me that it's in row 37. And then what this VLOOKUP does is it says, okay, look up number 37 in column B. So it's going to go down to column B, it's going to find 37, or 36, sorry, it's going to tell me 36. It's going to look up 36, and then it's going to report back with the age, with 27. So that's what this 3 is. It's saying, okay, look up the row that matched the largest number in column A and report back the 3rd column over from that label. And so it's going to report back the age. And I've done that for each one of these, but as I move down, here I did the largest, here I did the 2nd largest, the 3rd largest, the 4th largest, and then lastly the 5th largest. Okay. So that gives me 5 random numbers. Okay. Now I'm going to have this set up for you so that you don't have to worry about that, but if that's something you're interested in, take a look at it. Now what we want to do is we want to calculate the mean of our sample. So this sample right here has a mean, an average. Okay, so I'm taking the average of those 5 numbers. So it has a mean of 27.4. Now, we know we calculated the actual mean of all of these players is 28.44. So 27.4 is not the correct mean. In fact, with only 5 players, we can't even get the actual mean because dividing by 5 would never result in something like 0.44. Okay, so as long as we're dividing integers here. So we know that this sample mean is just an approximation. It's just an estimate of this actual mean. So we're going to use this estimate of the mean to help us construct our confidence interval. We also need to know the standard deviation of these values. How spread out are they? Okay, so again, that's STDEV, and then we select our value. So we're taking the standard deviation of those values, and that tells us that they're spread out. Their spread is about 4.278. Okay. Now, if we think back to our confidence interval formula, which we had right here, X bar, that's this here, that's the mean. Okay, so that's the mean of our sample. So we've got that. That's 27.4. Z star, that's what we're going to, I said we're just going to use 2. Okay, 95% of our data approximately is within 2 standard deviations of the mean. So we're going to simplify things, and we're going to say that Z star is 2. Okay. Sigma is the population standard deviation. Well, we're going to use our sample standard deviation. Okay, so we're going to use this 4.278. Now, technically, if we're using the sample standard deviation, we should be using something a little bit different than this Z star here that we said, a little bit different than 2. But again, that's something for another class. We're keeping it simple here. Okay, your Z star, always going to be 2 for this class. Okay, because that's 95% confidence interval typically contains 2 standard deviations of your data. And then N, that's our sample size, and our sample size is 5. Okay, so we have everything we need here. X bar, 27.4. Z star, 2. Our standard deviation is that 4.278. And N, our sample size is 5. Okay. So what I'm going to do then for my lower bound, I'm taking my X bar, I'm taking G7, my mean, and I'm subtracting 2, that's the Z star, times G8, times the standard deviation, divided by the square root of 5, because 5 is my sample size. So everything in this formula here is coming from this formula right here. Okay? And that's going to give me my lower bound. Upper bound is the exact same formula, except we put a plus here, because now we're going to take the mean and we're going to add something to it. So the mean is always going to be the middle of our confidence interval, because we're subtracting something from one side and we're adding something to the other side. And it's the exact same amount on both sides. So for this example, we got a confidence interval of 23.6 to 31.2. So I'm just going to copy that so that we can talk about what that means. I'm going to do a little paste special here and just paste those values. So what we're saying here is that we are 95% confident that the interval from 23.6 to 31.2 captures the true mean age of Milwaukee Brewers players. Okay, that's what our confidence interval tells us. We're 95% confident that this interval captures the true mean age. Okay? And in fact, this interval does, because the actual mean is 28.44, and that's in between 23.6 and 31.2. All right, so now what I want to do is I'm just going to come over here, and as you can see, and I'm going to shrink this a little bit, I have already done this. I've done 4 columns of 25. I went through and I did this 100 times. Okay? Now it's not that difficult. What I did is I said, okay, I'm going to mark down a 1 if my confidence interval captures this 28.44. So I look, 28.44 is between 22 and 30. So that worked. So I would type in a 1, and then I just hit enter, because every time you type a value in, your random numbers over here change. So then I could look at the next confidence interval. 22.9 to 29.8, that also captures the mean. And so I can keep doing that, and eventually I'll find some where it won't actually capture the mean. Okay, so nothing yet here. So here's one. Our lower bound is 30.5. Our upper bound is 33.9. 28.44 is not in that confidence interval. Okay, so that's one confidence interval that actually missed out on capturing the actual mean. And you can see why. Because the actual mean is 28.44, and all 5 players that we got were over 30 years old. So we just happened to have a sample that was a little bit high. Okay? And that'll happen, but we expect that to happen only about 5% of the time because we are 95% confident. Okay? So over here I did that 100 times, and in those 100 times, 89% of them captured the true mean age. Now, as I said, this is a 95% confidence interval. Why isn't it 95%? Again, that's due to randomness. Okay? Over many, many, many trials, we would expect this to capture the mean 95% of the time. This was only 100 trials, which may seem like a lot, but when you're talking about probability, we want to do things hundreds, thousands, millions of times. Okay? And that's what we're saying is over all that, we would expect 95% of those confidence intervals to capture the true mean. So 89% is actually pretty close to 95% if we're thinking about it in that respect. Okay. Something else I want you to think about is this formula here. If we wanted, so let me actually just say this part here, so the part in red here, that is our margin of error. Okay, so this z star 2, that's going to be the same for all 95% confidence intervals that we make in here. So that doesn't change. So the only thing that might change here, that might change the size of our confidence interval, is either our standard deviation or n. Well, we can't do much about the standard deviation because that's kind of, that's based on the population. But what we can do something about is n. Okay, so think about the bigger n is, that's our sample size. That means the smaller this fraction is going to be, which means the smaller this margin of error is going to be. So the bigger we can choose our sample size to be, the smaller our margin of error will be, and the more condensed our confidence interval will become. So if we want a smaller confidence interval, we need to increase the sample size. Okay? If we have a smaller sample size, then that's going to increase the size of our confidence interval because we're less certain about our results. Okay? So this is one example of how to construct a confidence interval and how to interpret it. I'll probably try to post one more video going through another example. Thank you.